Today's objective, volume. And we're going to focus on volume of cylinders, cones, and spheres. Let's go over some definitions. Volume, the number of cubic units needed to fill the space inside a 3D figure. Cubic unit, a cube whose edges are 1 unit long. A cone, that's a solid, that's a 3D figure with one circular base. So picture an ice cream cone when you're thinking about that. A cylinder is a solid, which is a 3D figure with 2 circular bases, top and bottom. So picture a can, a Pringles container. Sphere, it's a solid, a 3D figure with every point on the surface that's the same distance from the center. Think of a ball. So from the center of that sphere, the radius is going to be the same distance to every point that's on the outside of that sphere. Vic number 1, to find the volume of the cylinder, you find the area of the base and multiply it by the height of that 3D figure. Vic number 2, because volume uses all 3 dimensions, it is written with cubic units, units cubed. Okay? Vic number 3, the B in the formula, and we'll talk about those formulas in a second, stands for the area of the base in that 3D figure. So for volume formulas, let's talk about cylinders. Volume equals that big B, okay, which we know in Vic number 3, it talks about the area of the base times the height. So when you look at a cylinder, what is that base? It's a circle. So what is the area of that circle? Pi r squared. So area of the base times the height. So pi r squared times the height. And you would get those, whatever that situation would be, plug in those variables. Cone. What is the area of the base in a cone? Well, again, in a cone I have a circular base. And notice though that like a cylinder, the volume is the same all the way as it goes all the way up. But notice in the cone, it comes to that one common vertex. So the volume is definitely different than the cylinder. So that's why we would have this 1/3 on the outside. Okay? And it would take 3 cones to fill a cylinder. So that's why we divide by multiply by 1/3 or divide by 3. Big B times the height. So the area of this base is pi r squared times the height. All right, sphere. With hemispheres, in other words, if I chop this ball in half, this is how the formula is derived. This is where the 4/3 comes in. So 4/3 pi r cubed. Pi r cubed. So we have the length, the width, and the height, which is just the radius. If you look at all 3 of them, that's why the r is being cubed. So this is the one that usually gets a lot of students. Okay? So, or you can separate the fraction and rewrite it like this. Okay? Either way is acceptable. All right, volume of a cylinder. Here's your example for this. So I notice I have a diameter of 9 centimeters. The height of this cylinder is 5 centimeters. But I know I need for the formula is my radius. So I need to take that 9 centimeters and I need to chop it in half, which is 4.5. So that is what I'm going to use when I plug in. So cylinder, remember, is the big B times the H, the area of the base times the height. That's what I wrote here. So my base is a circular base, so the area formula is pi r squared times the height of that figure. So notice I take the height, which is 5, plug it in for my H, my radius, plug it in for my r. Don't forget that this radius is squared. Don't forget that. Pi r squared. Once I square 4.5, so I square my radius, I get 20.25. And I'm going to bring pi along for the ride. Then I multiply the height times my radius squared. I get 101.25. Remember, pi comes. This is the point where I need to understand what it is that I'm doing mathematically, okay, with the numbers. We know that pi is 3.14159,265, and it just keeps going. We know that it's 3 point, and it's infinitely. It keeps going. However, we're going to use 3 to help us approximate what that volume might be. Remember, we can't use a calculator, so we need to use that as far as understanding what's happening with the numbers. So if I take 101.25 and I multiply it by 3, I get 303.75. But again, pi is not 3. Pi is more than 3. So that means that my volume is more than 303.75. Not by much, but it's more than that. So that's what this statement is saying. We know that pi is definitely more than 3. That is why we know that the volume is going to be more than the numbers we just produced when we multiplied. Okay, if when I plugged 101.25 times pi, and I use actually the pi symbol in my calculator, this is what spit out. So that is very close in using, the number sense on understanding what it is that I'm doing. Remember, we cannot use a calculator. So therefore, I need to understand the number sense of this. Okay? All right. Volume of a cone. Remember a cone? Remember it takes 3 cones with the same height, same radius as a cylinder to fill a cylinder. That's why we have to, with the cone being distorted in the volume, divide by 1/3. The big B times the height. So I take 1/3 area times area of the base and also the height. So again, pi r squared. So here I'm actually given my radius of 8 centimeters and my height is 12. So I need to plug those in. Don't forget to square your radius, which I got 64. Bring down your pi. Now notice what I did with the 1/3. I saw right away that I was given something that 3 could go into evenly. So I went ahead and I just took care of that. Okay? So here, 3 went in 12, so I went ahead and I simplified that. And so I could definitely deal with 4 instead of having to take 12 and multiply it by all this. So I think 4 would be an easier number to work with. Now, what's going to happen when 3 doesn't go into that? I'm going to show you that. In that example, I'm going to show you on sphere when we get to that one. Okay, so 8 squared, 64. Bring your pi down. The 3 and the 12 simplified to a 4, so we brought that down. So now I need to multiply 4 and 64. I get 256. Don't forget your pi. Again, this is where I was telling you about the number sense. When I take 256 and I multiply it by 3, notice I get 676. Okay, 768. Pi is greater than 3. We agree there. So that means that I know I'm using the multiplication of 3 to help me approximate. So by doing that, that's why I always put this plus symbol. And notice that when I actually put this in my calculator, look what the actual volume is. That is what actually spits out. Okay? So remember, we know that because pi is more than 3, that my volume is going to be, that number is going to be more than the number that we get when we multiply. Alright, last example. We're going to talk about sphere. Okay? So again, sphere, the formula is derived 4/3 pi r cubed. Don't forget the cube. I know you're used to squaring everything in the previous figures. Alright, so 7 cubed. Well, 7 cubed, we know one of those, that's 343. Or 7 times 7 times 7, 343. Now this is where I was talking about the number sense part. Pi over 3, which is this, yes, I know that we do not need to do anything because it's kind of like a balancing act. That if I multiply something by 3 and I divide by 3, I'm kind of getting right where I'm at, except don't forget, pi is a little more than 3. So I know that when I'm finished with everything, it's definitely going to be a little more than that number. Okay, I'm not going to sit there and multiply something by 3 and then turn around and divide by 3, which is what we would normally do here in the calculations. So that's what we need to know, is that pi is not 3, but it's definitely more, and that's why when I take 343, I multiply it by 4, I get 1,372. Notice I put a plus here. When I plug this in my calculator, I get this as the volume. And I put the plus on here because there's definitely more digits there. 1436.76 cubic centimeters. Don't forget this part. We're going to be practicing this a lot in class.